Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Global Round 22, which was rated for all divisions, I guess. And let us quickly start with the first question, which is Glory Addicts. So this particular question says that a hero has n skills and the ith skill is of type either fire or frost. You can consider it 0 or 1, and each of the skill has a damage associated with it. So if a particular, so it says, I'll leave the brief. For example, if there are skills of two types, which is 0 and 1. If you perform us, and each of them has a damage associated to it, for example d1 and d2, right? Now it says that if I perform one skill and I perform the next skill of a different type next to it with the damages d1 and d2 respectively, then the total damage dealt would be d1 multiplied by twice plus d2, right? So whenever there is like two consecutive different of those skills, like if they are different, so one of them, the first one of them would get multiplied by 2 and the other would remain same, right? But if there are 0 and 0 and it is d1 and d2, it would be still d1 plus d2, right? Similarly for 1 1 d1 d2, it would be d1 plus d2, and again for 1 0 d1 and d2, it would be twice of d1 plus d2. So this is what our question is saying right now, right? So we have to find the maximum damage that we can deal with the given data. Now it is obvious that we need to maximize the numbers of alternate sequences, right? So our first observation is that, our observation number one is that maximize the alternate sequences. The second observation is that we need to take damages, like we need to take the skills with higher damage first, so that it can be multiplied by 2 and we can increase the overall cost effectively or overall damage effectively. So we want to take greater damage first, right? And the third thing is that, so for example, if we have sorted all the damages in the decreasing order, now there will be only two possibilities. Either I can take the skill with 0 1 0 first and then 0 1 0 1 I continue doing this, or I can take the skill with 1 first and then continue doing this. So these are the only two cases I need to consider to form my answer. So let us have a look at the code now. So I've taken an integer n and I've created two vectors a and b, right? So I'm taking the input in vectors x and y, where x is storing the type of the skill and y is storing the damage of the skill, right? So I traverse through from 0 to n. So if x of I is 1, I push it into a, if otherwise I push it into b, right? Now I am sorting both the vectors in reverse order, both the vectors a and b, which is consisting of the damages of my skill. Now I initialize my so I can just remove this variable because I'm not using it anywhere else. So I have initialized two pointers I and j, which are both at 0, right? And I have initialized also two sums, which is sum1 and sum2. So first I am calculating for sum1. Calculating for sum1, right? So I have initialized a boolean variable p is equals to 0. Now in this particular thing, what I am doing is, if I'm taking all the value, I am taking the b part first. So b consisted of all the skills which had type 0, right? So what I'm doing is I'm taking the type 0 skill first and I'm XORing p with 1. So from 0 it becomes 1 and from 1 it becomes 0 again. So this works like this. So every time once I take a skill of type 2 or type b, other time I take a skill of type a, right? So I've initialized p with 0, and at the end I'm taking all the remaining skills which are left, right? So now similarly I can calculate the sum2. So this particular code and this particular code is exactly the same. The only difference is here I initialize p with 0 and here I have initialized p with 1. So first in this particular part, the else statement gets executed first, and in this particular part the if statement gets executed first. So in one case I am taking the b skills first, and in the other case I am taking the a skills first. So this will have this, in this way I'll have two results, sum1 and sum2, and at the end I can just print the maximum of sum 1 and sum 2, and this would be my final answer. So let us quickly move on to problem B for today's contest, which is prefix sum addicts. Now this particular question says that we have been given a sorted sequence of integers. So it is actually sorted sequence of integers, and we have been given the last k terms of the prefix sum of that sequence, right? So we have been, so for example, there is a sorted sequence and we have been given the last k terms of prefix sums of that sorted sequence. So I believe all of us already know what prefix sums are. If let me just explain quickly what actually prefix sums are. For example, if this is my array A, I'll calculate my prefix sum as, so this is 1, the first element remains as it is. Now this is 2, so I'll add 2 to 1, this will become 3. This is 3, I'll add 3 to 3, this will become 6. This is 4, I'll add 4 to 6, this will become 10. And this is 5, I'll add 5 to 10, this will become 15. So this is my prefix sum array. So here the value of n is equals to 5. Right. Now the question says that we have been given the last k terms. For example, if k is equals to 2, we will be given 10 or 15. We have to find whether it is possible to construct a sorted array A such that these are the last two terms of the prefix sum of that array. Right. So this is last k terms or last two terms, whichever is given in the question, we can say. So we have to tell whether there exists a sorted array A such that this particular part belongs to the last k terms of that prefix sums belonging to that array. So this is our question. Now the first thing that you will notice is, if we have been given the prefix sums, right? So if we do not talk about the first element, we can talk about the rest of the elements, right? So if this we take these two elements, I can get the second element, right? 3 minus 1, I can get the second element. And when I do 6 minus 3, then I can get the third element, right? So in this way, if we leave the first element for now, for all the elements starting from position 2 to k, we can find those elements, right? Those elements which are present in the actual array from the prefix sums vector itself. For example, if this is the prefix sum vector, I can find all the values, I can find all the values other than the first value, right? We can find the exact values which might be present in our array, right? So if this is my prefix sum array, this is my 0th position, this is my first position, second, third and fourth position, and I can construct my original array. This is 3, this is A, so this is also 0, 1, 2, 3. So if you see, if I do 3 minus 1, I can get 2. If I do 6 minus 3, I can get 3. If I do 10 minus 6, I can get 4. If I do 15 minus 10, I can get 5. So I have recovered my original array from the prefix sum array, and I have recovered all the values except the first value, right? So for this part, I can straight away check whether these values are present in sorted order or not, right? So for it to be present in sorted order, this particular value should be less than or equal to the second value, right? So we can just start a loop and we can check, for example, if this is the ith position, we can check if v of I minus v of I minus 1 is greater than v of I plus 1 minus v of I, right? So if it is greater than, then the answer would be straight away no. In this case, our answer is no. So this is observation number 1. Because we can already find all the other elements except the first element, and we can just check it. So how do we check the first element? You will observe that if this is the difference, right? For example, 3 minus 2, 3 minus 1, then the element is 2, right? So all the other elements present after 2 in a sorted array would be at least equal to 2, right? So all the other elements present after 2 should be at least equal to 2, right? So if the first element that is given in the prefix vector, if it is greater than 2 into n minus k plus 1, so n minus k plus 1 is the remaining elements. For example, if there are n minus k plus 1 elements and all of them are 2, there should be at least 2, and this value is smaller than the first value itself, and the answer would be no. Right, so this is observation number 2. And in all the other cases, the answer would be yes. So for observation 2, I am just assuming that all the other values should be at least equal to 2, and this first value should be less than or equal to all the other values multiplied by the this particular value multiplied by the remaining number of values. Right? If it is greater than, then the answer should be exactly no. Now let me show you the code for this particular question. So I have taken two integers n and k as input. I create a vector v of size k and I take the input in it. So if k is equals to 1, then the answer would always be yes. Right? So this is a pretty simple base case. If k is equals to 1, I can arrange all the values around it in any way I want, and I can form the final result in increasing order. Otherwise, I just start c. C is the last taken element. I initialize it with infinity, and from 2 till less than k, I just check if c is greater than v of I minus v of I minus 1. So c here is this part. So I am taking initially c as infinity, minus infinity, and I am checking if c is greater than the difference of this. Then I am checking if c is greater than the difference of this, because at any time if c is the last taken element is greater than the difference of the next, it's greater than the next element, which is v of I minus v of I minus 1. So the answer would be no. In all of the cases, I'll update the c as v of I minus v of I minus 1. So this will be my next element, and I again compare it with the next element. So this keeps on going, and I print a no whenever I find a contradictory part. Right? Now I initialize my valid. So I didn't find any contradictory part here. So here I initialize my valid variable as true. So I just check if v of 0 is greater than v of 1 minus v of I multiplied by the number of remaining elements. If this is true, then our answer is not possible, and I set valid as 0. And I just check if valid. If it is valid, I just print yes, otherwise I print no. So this was the solution for the second question. Now let us move to the third question. So this particular question is even number addicts, and it says that Alice and Bob are playing a game on the sequence of length n, and like they move in turns, and Alice moves first. So it says that if each player in his or her turn, they should choose exactly one integer from the sequence and remove it from the sequence, and they add it to the sum. Right? So Alice wins if the sum of all the selected integers is even, otherwise Bob wins, right? And they both have to play optimally, right? So this is a question, and I'll tell you how I've done it with the DP approach, and I'll explain you how. So the sum should be even, right? The sum of all the elements, all the integers taken by Alice should be even. Now let me just discuss the DP states, and then I'll show you the code, because I feel like there's no point demonstrating it. It would be better if I directly show you the code. Before that, let us discuss the DP states that I'll be using. So I'm using a 3-dimensional DP I, J and K. So DP of I, so I stores the odd numbers, number of odd numbers remaining, J stores the numbers of even numbers remaining, and K stores the parity or the current sum. If the current sum is even for Alice, then it will be 0. If the sum is even, 0 if even sum. If you're talking about the current sum is even, it is 1 if the current sum is odd. Right? So this will store either 0 or 1. It will store 0 if Alice will lose. It will store 1 if Alice will win from this particular state. Right? Now this is the DP state that I'll be using, and let me show you the code and I'll explain you side by side. So first of all, I just initialize the DP array of size 100, 101 and 2. So why I'm taking 101? Because the maximum value of n is up to 100, right? So at max there can be 100 even numbers or 100 odd numbers, right? So now I just run a loop from 0 to 101. In this particular loop, what I'm doing is, if there are 0 odd numbers and all of the other are even numbers, right? If there are 0 odd numbers and all the remaining are even numbers, then obviously if the current sum is even, then the answer would be true, or Alice will win. Otherwise, Alice will not win. Right? This is very simple. right? Now, if there is only one odd number remaining, now I'm again running a loop. If there is only one odd number remaining and the current sum is odd, right? So in this particular case, obviously Alice will take that odd number, right? And Alice would always win because all of the other remaining numbers would be even, right? Now, if there is only one odd number, right? And there are even number of even numbers. So let me discuss this carefully. Right. So if there is only one odd number and there are even number of even numbers, right? So and the parity is 0. So current sum is even. So this is the case, even number. In this case, answer will be 0. Otherwise, the answer will be 1 or true, or Alice will win. So the current sum is already even, right? Current sum is already even. Now, if Alice takes this particular odd number, then it will become odd and Alice will always lose. But if Alice takes this even number, what will happen is Bob will take this even number and Alice will have to take this number. So again, Alice will lose, right? But if the number of even numbers is odd, then Alice can safely take this even number and Bob will have to take this odd number, right? So in this way, whenever there is only one odd number remaining and the number of even numbers, there are two cases, and this is the sum is 0, the current sum is 0. If I is odd, then the answer would be 1. If I is even, then the answer would be 0. So these are all the base cases that we have to discuss, right? So I've discussed all the base cases and we can form all the cases from this only, right? So I just run a loop from 2 to 101. So this will be for odd numbers. 0 to 100, this will be for even numbers, and from k 0 to 2, this will be for the parity or the current sum, right? So I am just taking two Boolean variables, whether Alice can take a odd number, take an odd, or Alice can take an even number, take an even, right? So now I just consider my first case and I initialize with lose1, which is equal to 0. So if Alice takes odd, now Bob will have two choices. Bob can also take odd and Bob can also take even, right? If Bob takes odd, then he can only take it if I minus 2 should be greater than minus 1, which means that I is the current number of odd numbers. If I subtract two odd numbers from it, then it should be greater than minus 1, right? Obviously, otherwise both Alice and Bob cannot take odd numbers. If this is possible, then I'll do lose 1 or is equals to, I'm ORing it with this value dp of I minus 2, which is like the number of odd numbers will decrease by 2, the number of even numbers will remain same, and since Alice has taken an odd number, the parity will change. If the sum is odd, it will become even. If the sum is even, it will become odd. So if it is equal to 0, then Alice will lose in this case, and this is what I am storing in lose1 Boolean variable. Now the other case is if Bob takes even. So for Bob to take even, j minus 1 should be greater than minus 1, right? So again, I'm initializing lose1 or is equals to dp of I minus 1, one odd number taken by Alice, one even number taken by Bob, and k XOR 1, which is like the parity will shift. So if it is equal to 0, Alice will lose in this case, and taken odd is marked as 1, which means Alice can take the odd number, right? Similarly, again, Alice takes even. So I am initializing of lose 2 as 0. So if Alice can only take the even number if the value of j is greater than 0. Now again, there are two cases, Bob takes even, Bob takes odd. So Bob can only take even if j minus 2 is greater than minus 1, right? So lose 2 will be, the number of odd numbers will remain same, the number of even numbers will decrease by 2, and the parity will remain same since Alice is taking an even number. So if this is equal to 0, then Alice will lose in this is lose 2 variable, right? If Bob takes odd, then I minus 1 should be greater than minus 1. Again, the same thing. If lose 2 is, I'm taking decrementing odd numbers by 1, decrementing even numbers by 1, and the parity remains same. If it equals to 0, then Alice will lose and I'm taking even, right? So for this particular case, I am initializing Boolean result. So if there is a way to take an odd number and if there is a way to take an even number, if both of the ways exists, and in both of the ways Alice is losing, so lose 1 and then lose 2, it means lose 1 is true and lose 2 is true. In both of the ways Alice is losing, then result will be equals to 1. So result is storing. RES will store if Alice will lose. So if both of the methods are possible, then it will be equal to lose 1 and lose 2, because result will always be true when Alice is losing in both of the ways, right? Else I'll take a odd value of lose 1 and lose 2, and it can so because you cannot take both even and odd, either you can only take odd numbers or you can take even numbers, like at the current position, then it will be the odd value of lose 1 and lose 2. So if Alice is losing in even one of them, then Alice will lose, because either she was taking one and she lost in this, or she was taking one and she lost in this. So result will be lose 1 or lose 2. Now if Alice is losing, then the value of dpijk should be equal to 0, because at dpijk I am storing 1 if Alice wins, else 0, right? So if result is equals to 1, then it means Alice will lose and I have to store 0 in it. So I am taking XOR with 1. If result equals to 0, then it means Alice will win and I am storing 0 XOR 1, that is 1 at this particular position. So I have finally created my DP array, and at the end I can just take the vector input n for every input. I can just traverse through it, and if it is odd, I can increment the count of odd by 1, otherwise I can increment the count of even by 1, and I can check if DP at odd, even and parity is 0 initially because the sum is 0, right? If it is 1, I can print Alice, otherwise I can print Bob. So this would be the solution for the third question with DP, and there might also exist some solutions with a bit of casework, but this is the most optimal approach with DP. So I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.